When you gaze up at the night sky, what do you see? Stars, planets, maybe the faint glow of a distant galaxy. But what about the vast, invisible universe that lies just beyond our perception? What about the forces and phenomena that shape the cosmos but remain hidden from our eyes? This is the story of the unseen and the remarkable individuals who dedicated their lives to mapping it. Scientists whose names have been lost to history, but whose discoveries changed everything we know about the universe. Imagine a world where the work of a single mind could unlock secrets that had puzzled humanity for centuries. Now, imagine that same mind being forgotten, their contributions overshadowed by time. It's a mystery within a mystery. Why do some of the greatest scientific breakthroughs come from those who remain unsung? Who were these forgotten pioneers, and what did they uncover about the invisible fabric of reality? This video is a journey into their extraordinary lives, a tribute to their brilliance, and a chance to explore the questions they left behind. From the shadows of history, we'll uncover the stories of those who dared to look beyond what was visible, who charted the unknown with nothing but curiosity and determination. Their work laid the foundation for modern science, yet their names are rarely mentioned. Why is that, and what can we learn from their legacy? As we delve into their discoveries, you'll find yourself questioning how much of our understanding of the universe is built on the shoulders of these hidden giants. Prepare to be amazed, inspired, and perhaps a little humbled as we shine a light on the forgotten scientists who mapped the invisible universe. This is more than just a story about science. It's a story about human ambition, the relentless pursuit of knowledge, and the quiet heroes who changed the world without ever seeking the spotlight. So let's begin this journey together and uncover the secrets they left behind. The invisible universe is like an iceberg. What we see, the stars and galaxies, is just the tip. Beneath the surface lies a vast, hidden world that shapes the cosmos in ways we are only beginning to understand. Dark matter, an invisible substance that doesn't emit light or energy, makes up about 85% of the universe's mass. It's the glue that holds galaxies together, yet we can't see it directly. Then there's dark energy, an even more mysterious force driving the accelerated expansion of the universe. Together, these invisible elements make up 95% of the cosmos, leaving the visible universe as just a tiny fraction of what's out there. The idea that most of the universe is hidden from our eyes isn't new. Centuries ago, philosophers and scientists speculated about unseen forces guiding the motions of celestial bodies. Isaac Newton wondered about the nature of gravity, an invisible force that seemed to act across vast distances. Later, Albert Einstein's theory of general relativity provided a deeper understanding of how mass and energy bend the fabric of space-time, hinting at the existence of phenomena beyond what we could observe. Today, astrophysicists continue to grapple with these questions, using cutting-edge tools and theories to probe the invisible universe. Yet, for all our advancements, the challenges remain immense. Imagine trying to map something you can't see, something that interacts with the visible world only through subtle gravitational effects. It's like trying to trace the outline of a shadow in a pitch-black room. The scientists who first ventured into this uncharted territory faced skepticism, limited technology, and the daunting task of proving the existence of something that defied detection. Their work laid the groundwork for our modern understanding, but their names often faded into obscurity. Who were these pioneers, and what drove them to explore a world they knew they might never fully see? Their story is one of curiosity, perseverance, and the unshakable belief that the universe holds secrets waiting to be uncovered. In the early 1930s, a Swiss astronomer named Fritz Zwicky made a discovery that would shake the foundations of astrophysics. While studying the Coma galaxy cluster, Zwicky noticed something strange. The galaxies were moving far faster than expected based on the visible matter alone. He proposed the existence of something he called dark matter, an invisible substance that exerted gravitational pull but emitted no light. At the time, the idea was met with skepticism. Many of his peers dismissed it as speculative, even absurd. Zwicky, known for his sharp wit and bold personality, famously referred to his critics as spherical bastards because, as he put it, they look the same from every angle. Despite the resistance, Zwicky persisted, using detailed observations and mathematical models to support his claims. Around the same time, another scientist, Vera Rubin, began studying the rotation of galaxies. Her work revealed that stars on the outer edges of galaxies moved just as fast as those near the center, defying the predictions of Newtonian physics. Rubin's findings reinforced Zwicky's hypothesis, providing compelling evidence for the existence of dark matter. These early pioneers faced not only scientific challenges but also societal barriers. Rubin, for instance, encountered significant gender bias in her field, yet she remained undeterred, often saying, "Science progresses best when observations force us to alter our preconceptions." Their groundbreaking work relied on innovative methods. Zwicky used gravitational lensing to infer the presence of unseen mass, while Rubin meticulously analyzed the motion of stars across countless galaxies. Their persistence and creativity laid the foundation for modern cosmology, even though they never lived to see the full impact of their discoveries. As Rubin once noted, "We peer into a universe that is largely invisible to us, and yet it shapes everything we see." These scientists didn't just uncover evidence of the invisible universe, they challenged us to rethink our understanding of reality itself. Their legacy reminds us that progress often begins with a willingness to question the unknown, even when the answers remain just out of sight. Mathematics became the key to unlocking the secrets of the invisible universe, serving as a bridge between what we could see and what remained hidden. At the heart of this breakthrough were pioneering mathematicians who crafted elegant equations to describe the unseen forces shaping the cosmos. One of the most influential figures was Carl Schwarzschild, who in 1916 solved Einstein's equations of general relativity to predict the existence of black holes. Schwarzschild's work provided a mathematical framework for understanding these mysterious objects long before telescopes could observe them. Similarly, Subrahmanyan Chandrasekhar's calculations revealed that stars above a certain mass would collapse into incredibly dense remnants, now known as neutron stars or black holes. His discovery, initially met with resistance from the scientific community, later earned him a Nobel Prize. These mathematical tools didn't just describe what we already knew, they predicted phenomena that seemed beyond imagination. For instance, the equations of quantum mechanics, developed by figures like Erwin Schrödinger and Werner Heisenberg, provided insights into the behavior of particles on the smallest scales. These formulas allowed scientists to infer the existence of dark matter and dark energy, even though these substances remain invisible to direct observation. The power of mathematics lay in its ability to provide precise predictions. When Vera Rubin observed the unexpected rotation of galaxies, it was the mathematics of gravitational theory that confirmed her findings aligned with the presence of unseen mass. Similarly, the equations of general relativity accurately predicted the bending of light around massive objects, a phenomenon known as gravitational lensing. This intersection of mathematics and observational science became a cornerstone of modern cosmology. While telescopes captured the light of distant stars, it was the equations on paper that revealed the invisible forces at work. As one mathematician aptly put it, the universe speaks in numbers and it's our job to listen. This synergy between mathematics and observation continues to drive discovery, proving that sometimes the most profound truths are hidden not in the stars themselves, but in the patterns and principles that govern them. While the contributions of many scientists have shaped our understanding of the universe, the stories of women in this field often went untold for decades. Vera Rubin stands as one of the most remarkable figures, her work fundamentally altering our perception of galaxies. In the 1960s and 70s, Rubin meticulously studied the rotation of galaxies, discovering that stars on the outer edges moved just as fast as those near the center. This observation defied the expectations of Newtonian physics, hinting at the presence of unseen matter, what we now call dark matter. Her findings were met with skepticism at first, but her persistence and precision eventually convinced the scientific community. Rubin once remarked, "We're still groping for the truth. Science consists of making guesses and testing them." Her humility and dedication became an inspiration to countless young scientists. Another trailblazer was Cecilia Payne-Gaposchkin, whose doctoral thesis in 1925 revolutionized our understanding of stars. She proposed that stars were primarily composed of hydrogen and helium, a radical idea at the time. Though her work was initially dismissed, it later became a cornerstone of astrophysics. Payne-Gaposchkin faced significant barriers as a woman in a male-dominated field, yet she persevered, eventually becoming the first female professor and department chair at Harvard. These women didn't just advance science, they paved the way for future generations. Astronomer Margaret Burbidge, who played a pivotal role in understanding how elements form in stars, once said of her struggles, "The experience of being a woman in a man's world is not just a matter of being underestimated, it's also a matter of being invisible." Their stories highlight not only their scientific brilliance but also their resilience in overcoming societal obstacles. Recognizing their legacy is essential, not just to honor their achievements but to inspire a more inclusive future. As we continue to explore the mysteries of the universe, their contributions remind us that progress often comes from those who challenge the status quo. Their work, once overlooked, now shines as brightly as the stars they studied. The discovery of the invisible universe would have been impossible without the tools that allowed scientists to peer beyond the limits of human senses. One of the most transformative inventions was the telescope, which brought distant galaxies and nebulae into view for the first time. In the early 20th century, Edwin Hubble used the 100-inch Hooker telescope at Mount Wilson Observatory to observe galaxies far beyond our Milky Way, proving that the universe was expanding. This groundbreaking work laid the foundation for modern cosmology, but it was just the beginning. Decades later, the Hubble Space Telescope, launched in 1990, took our understanding to new heights. Free from the distortions of Earth's atmosphere, it captured breathtaking images of deep space, revealing the birth of stars, the collision of galaxies, and the existence of black holes. Another game-changing innovation was the development of particle detectors, which allowed scientists to study the elusive components of dark matter. These detectors, like the Large Underground Xenon experiment, operate deep underground to shield them from cosmic interference, tracking the faint signals of dark matter particles as they pass through Earth. Radio telescopes also played a crucial role, uncovering phenomena like pulsars and the cosmic microwave background radiation, the faint echo of the Big Bang. These technological marvels didn't just confirm existing theories, they opened entirely new avenues of exploration. What's remarkable is how these advancements were often the result of collaboration across disciplines. Engineers, physicists, and astronomers worked together to design and refine these instruments, pushing the boundaries of what was possible. The James Webb Space Telescope, launched in 2021, is a testament to this collaborative spirit. With its infrared capabilities, it peers through cosmic dust to reveal the earliest galaxies ever observed, shedding light on the universe's infancy. Technology has not only expanded our understanding but also democratized access to discovery, enabling scientists from around the globe to contribute to our collective knowledge. As these tools continue to evolve, they promise to uncover even more secrets of the invisible universe, reminding us that the journey of discovery is as boundless as the cosmos itself. The mystery of dark matter is one of the most profound puzzles in modern science. It all began in the 1930s when Swiss astronomer Fritz Zwicky observed that galaxies within the Coma cluster were moving far too quickly to be held together by the gravity of visible matter alone. He proposed the existence of what he called dunkle materie, or dark matter, an invisible substance that must account for the missing mass. Decades later, astronomer Vera Rubin provided further evidence when she discovered that stars at the edges of spiral galaxies were orbiting just as fast as those near the center, defying the laws of gravity unless some unseen matter was at work. But what is dark matter? We know it makes up about 27% of the universe, far outweighing all the stars, planets, and gas we can see. Yet it doesn't emit, absorb, or reflect light, making it invisible to traditional telescopes. One of the most compelling pieces of evidence for its existence comes from gravitational lensing, a phenomenon predicted by Einstein's theory of general relativity. When light from a distant galaxy passes near a massive object, the object's gravity bends the light, acting like a cosmic magnifying glass. In some cases, the amount of bending is far greater than what the visible matter alone could produce, pointing to the presence of dark matter. Today, scientists are racing to uncover its true nature. Experiments like the Large Hadron Collider are smashing particles together at incredible speeds, hoping to create dark matter in the lab. Meanwhile, detectors like the XENON1T project are buried deep underground, shielded from cosmic rays, waiting for the rare moment when a dark matter particle interacts with ordinary matter. Despite these efforts, dark matter remains elusive, a shadow in the cosmic void. As physicist Dr. Tracy Slatire of MIT puts it, "We're chasing something we know is there, but we don't yet know what it is." It's both frustrating and exhilarating, and while dark matter continues to baffle us, it's closely tied to another cosmic enigma, dark energy, the mysterious force driving the accelerated expansion of the universe. Together, these invisible forces shape the cosmos in ways we're only beginning to understand. The discovery of dark energy reshaped our understanding of the cosmos in ways that continue to astonish scientists and stargazers alike. At the end of the 1990s, two teams of astronomers, led by Saul Perlmutter and Brian Schmidt, were studying distant supernova to measure the rate at which the universe was expanding. They expected to find that the expansion was slowing down due to gravity's pull. Instead, they discovered the opposite. The universe was expanding faster and faster, as if some mysterious force was pushing it apart. This force, which came to be known as dark energy, accounts for a staggering 68% of the universe's total energy content. Yet, like dark matter, it remains invisible and undetectable by conventional means. What makes dark energy so perplexing is its ability to defy gravity on the grandest scales. While gravity pulls matter together, dark energy seems to push it apart, acting as a kind of anti-gravity that accelerates the universe's expansion. This discovery challenged fundamental assumptions in physics and forced scientists to reconsider the fate of the cosmos. One leading theory suggests that dark energy is a property of space itself, often referred to as the cosmological constant, a term Einstein once proposed and later dismissed as his greatest blunder. Another possibility is that dark energy is a dynamic field, changing over time and potentially altering the universe's expansion rate in unpredictable ways. Yet, despite decades of research, its true nature remains elusive. As physicist Dr. Dragan Huterer puts it, dark energy is the biggest mystery in science today. It's not just about understanding the universe, it's about understanding the very fabric of reality. The implications of dark energy are profound. If it continues to drive the universe's accelerated expansion, it could lead to a future where galaxies are so far apart that they become invisible to each other, leaving civilizations isolated in an ever-expanding void. On the other hand, if dark energy changes over time, it could lead to a big rip, tearing apart galaxies, stars, and even atoms. These possibilities remind us of how much we still have to learn about the cosmos. And while dark energy and dark matter may seem like separate mysteries, they are deeply interconnected, both shaping the universe in ways we are only beginning to comprehend. Together, they challenge us to rethink our understanding of physics, space, and time, inviting us to explore the unknown with curiosity and wonder. The history of science is filled with brilliant minds whose ideas were overlooked or dismissed only to resurface decades or even centuries later as groundbreaking discoveries. Consider the story of Fritz Zwicky, the Swiss astronomer who first proposed the existence of dark matter in the 1930s. While studying the Coma cluster of galaxies, Zwicky noticed that the visible mass of the cluster was far too small to account for the gravitational forces holding it together. He termed this unseen mass Dunkelmaterei, or dark matter, but his peers largely dismissed the idea as speculative. It wasn't until the 1970s, when Vera Rubin's work on galaxy rotation curves provided compelling evidence, that the scientific community began to take Zwicky's theory seriously. Another overlooked figure is Georges Lemaitre, a Belgian priest and physicist who proposed the idea of an expanding universe years before Edwin Hubble's famous observations. Lemaitre's primeval atom theory, which suggested the universe began from a single point, was initially met with skepticism. Yet it laid the foundation for the Big Bang theory, one of the most widely accepted models of cosmology today. Similarly, British astronomer Arthur Eddington theorized the existence of dark radiation in the 1920s, an idea that might align with modern concepts of dark energy. Eddington's work was ahead of its time, and his peers struggled to grasp its significance. These stories remind us that scientific progress often depends on the willingness to challenge conventional wisdom. Many of these forgotten theories faced resistance not because they were flawed, but because they pushed the boundaries of what was considered possible. Scientists like Zwicky, Lemaitre, and Eddington were visionaries who dared to think differently, even when their ideas were unpopular. Their contributions highlight the importance of perseverance and open-mindedness in science. While some theories were eventually validated, others remained speculative, waiting for future discoveries to confirm or refute them. This ongoing process of questioning, testing, and revising is what drives scientific advancement. It also serves as a reminder that even the most brilliant ideas can take time to be understood. As we continue to explore the invisible universe, we honor these pioneers by building on their work, challenging our assumptions, and embracing the unknown with curiosity and courage. Their stories inspire us to keep asking the big questions no matter how unconventional the answers might seem. The study of the invisible universe isn't just a product of modern science. It has roots in ancient philosophy, where thinkers dared to imagine what lay beyond the visible world. One of the earliest examples comes from Democritus, the Greek philosopher who lived over 2,000 years ago. He proposed that everything in the universe was made up of tiny, indivisible particles called atomos or atoms. At the time, this idea was purely speculative, as there was no way to observe or prove it. Yet, Democritus's vision of an unseen, microscopic world laid the groundwork for the scientific study of matter. Centuries later, his ideas would resurface in the work of chemists like John Dalton, who developed the atomic theory that forms the basis of modern chemistry. Beyond atoms, philosophers like Anaximander imagined the cosmos as an infinite, boundless space, a concept that echoes in today's discussions of a potentially infinite universe. These early thinkers didn't have telescopes or particle accelerators, but their curiosity and imagination set the stage for scientific exploration. The connection between philosophy and science remains strong even today. Modern scientists often reflect on this legacy. Carl Sagan once remarked, "We are all connected to each other biologically, to the Earth chemically, to the rest of the universe atomically." This sentiment captures the enduring influence of philosophical inquiry on scientific thought. Similarly, physicist Carlo Rovelli has noted how the questions posed by ancient philosophers still resonate in contemporary physics, particularly in the study of quantum mechanics and cosmology. The interdisciplinary nature of discovery reminds us that science and philosophy are not separate endeavors, they are two sides of the same coin. While science seeks to explain the how, philosophy often explores the why, guiding us toward deeper questions about existence, reality, and our place in the universe. This interplay continues to inspire new ways of thinking, proving that the quest to understand the invisible universe is as much about imagination as it is about observation. By embracing both disciplines, we honor the legacy of those who dared to dream of worlds unseen, and we continue to push the boundaries of what we know. Behind every famous scientist, there are countless individuals whose names we rarely hear: assistants, technicians, and junior researchers whose contributions were just as vital to the discoveries that shaped our understanding of the universe. Take, for example, the story of Cecilia Payne-Gaposchkin, whose groundbreaking work on the composition of stars was initially overshadowed by her male colleagues. Payne's thesis, which established that stars are primarily made of hydrogen and helium, was dismissed by the scientific establishment at the time. Yet, her meticulous research laid the foundation for modern astrophysics. Similarly, consider the role of Milton Humason, a janitor-turned-astronomer who worked alongside Edwin Hubble. Humason's skill in capturing detailed photographs of distant galaxies was crucial to proving the expansion of the universe, yet his name remains largely unknown. These stories are not exceptions, they are reminders of how many hands are involved in the process of discovery. Archival materials often reveal the fingerprints of these unsung collaborators. For instance, in the early days of radio astronomy, it was the tireless efforts of technicians like Grote Reber, who built his own radio telescope in his backyard, that allowed scientists to map the invisible universe. Reber's work was essential in proving that cosmic radio waves could be detected from Earth, yet his contributions were often overlooked in favor of more prominent figures. The importance of teamwork in science cannot be overstated. Even the most brilliant minds rely on a network of support to turn their ideas into reality. Whether it's the lab assistant who calibrates the instruments, the junior researcher who analyzes the data, or the technician who builds the equipment, each person plays a critical role. This collaborative spirit is what drives innovation forward. Without these unsung heroes, many of the breakthroughs we celebrate today might never have happened. Their stories remind us that science is not the work of individuals, it is a collective endeavor shaped by the dedication and expertise of many. As we continue to explore the mysteries of the universe, let's take a moment to honor those who have worked tirelessly behind the scenes, whose names may not be in the headlines but whose contributions are just as significant. War has always been a double-edged sword for scientific progress, bringing both disruption and unexpected opportunity. During times of conflict, the priorities of nations shift, often redirecting resources toward military applications rather than pure research. Many scientists found their work interrupted or even abandoned as they were forced to flee their homes. The upheaval of World War II, for example, displaced countless researchers across Europe, scattering them across the globe. Some sought refuge in the United States, where they continued their work under challenging conditions. Despite these hardships, the war also accelerated certain areas of study. The need for advanced radar technology, for instance, spurred breakthroughs in radio astronomy, allowing scientists to peer deeper into the cosmos than ever before. One notable project born from this era was the development of the cavity magnetron, a device originally designed for radar that later became instrumental in radio telescopes. Historians like Peter Gallison have noted that wartime pressures often forced scientists to think creatively, leading to innovations that might have taken decades to achieve in peacetime. Meanwhile, the collaborative efforts of displaced scientists fostered a sense of global unity in the face of adversity. Institutions like the Manhattan Project, though controversial, brought together some of the brightest minds of the era, demonstrating the power of collective intelligence. These projects also laid the groundwork for post-war scientific endeavors, including the exploration of the invisible universe. The resilience of the scientific community during these turbulent times is a testament to the enduring human drive to understand the world around us. Even in the darkest moments, curiosity and determination prevailed, proving that the pursuit of knowledge can transcend even the most daunting challenges. Sometimes the most profound discoveries in science come not from meticulous planning but from sheer serendipity. The story of cosmic microwave background radiation is a perfect example of how chance can unveil the secrets of the universe. In the mid-1960s, two radio astronomers, Arno Penzias and Robert Wilson, were working at Bell Labs in New Jersey, trying to calibrate a sensitive radio antenna. They kept encountering a persistent noise that seemed to come from every direction in the sky. At first, they assumed it was interference from nearby sources or even pigeon droppings on their equipment. But after months of eliminating every possible explanation, they realized they had stumbled upon something far more significant. This faint, uniform signal turned out to be the afterglow of the Big Bang, the oldest light in the universe. Penzias later recalled, "We were like a pair of high school kids who had just discovered the first clue to a mystery." Their accidental discovery provided the strongest evidence yet for the Big Bang theory and earned them the Nobel Prize in Physics in 1978. But they weren't the first to predict such a signal. Years earlier, a team led by Ralph Alpha and Robert Herman had theorized that the universe's expansion would leave behind residual radiation. However, their work was largely overlooked until Penzias and Wilson's discovery brought it to light. This story highlights the unpredictable nature of scientific progress. Often, breakthroughs happen not because of a clear roadmap, but because someone was in the right place at the right time, armed with curiosity and an open mind. As physicist Richard Feynman once said, "Science is the art of guessing nature's laws." These moments of serendipity remind us that the universe is full of surprises, waiting for the right observer to notice them. Behind every groundbreaking discovery in astronomy lies a tool that made it possible, often a device so ingenious yet so overlooked that its creators are barely remembered. Take the early spectroscope, for instance. In the mid-19th century, scientists like Joseph von Fraunhofer and Gustav Kirchhoff designed and refined this instrument to analyze the light from stars and other celestial objects. By splitting light into its component colors, they could identify the chemical composition of distant stars and even discover new elements like helium, which was first detected in the sun's spectrum before it was found on Earth. These early spectroscopes were marvels of precision, crafted with meticulous attention to detail, yet their inventors often faded into the background of scientific history. Another example is the interferometer, a device that Albert Michelson and Edward Morley used in the late 19th century to measure the speed of light with unprecedented accuracy. Their work paved the way for Einstein's theory of relativity, yet the interferometer itself is rarely celebrated as the revolutionary tool it was. These instruments were not just tools, they were gateways to new ways of seeing the universe. They required not only technical skill, but also a deep understanding of both physics and optics. The inventors behind them were often tinkerers and visionaries, blending artistry with science to push the boundaries of what was possible. As we look back, it's clear that these forgotten instruments shaped the course of astronomy in ways we're still uncovering today. From the humble telescope eyepiece to the complex detectors used in modern observatories, each piece of equipment represents a leap of ingenuity. Their evolution reflects the relentless curiosity of humanity, a drive to build, measure, and understand the cosmos, one observation at a time. Scientific journals have long been the lifeblood of discovery, quietly preserving the ideas that shaped our understanding of the universe. Many of these publications, now largely forgotten, were once the platforms for groundbreaking research that pushed the boundaries of what was known. Take the Astronomische Nachrichten, founded in the early 19th century by Heinrich Christian Schumacher. This journal became a hub for astronomers across Europe, publishing papers on everything from comets to the first detailed studies of the sun's spectrum. Yet, its contributors, often amateur astronomers or underfunded researchers, rarely received the recognition they deserved. Another example is the Philosophical magazine, which in the late 19th century featured pivotal work on spectroscopy and the nature of light, including papers by William Huggins and Norman Lockyer. These journals were more than just collections of articles. They were communities connecting scientists across continents and generations. The editors, like Schumacher, were often unsung heroes, tirelessly working to disseminate knowledge in an era when communication was slow and fragmented. Historians of science have noted that without these journals, many discoveries might have been lost or delayed. As one historian put it, these publications were the threads that wove the tapestry of modern astronomy. Today, we rely on digital archives to uncover these forgotten gems, but the journals themselves stand as testaments to the importance of record-keeping. They remind us that every discovery is built on the foundation of shared knowledge, a legacy that continues to shape our exploration of the invisible universe. The study of the invisible universe owes much to the contributions of amateur scientists, whose passion and curiosity have often led to remarkable discoveries. These individuals, often working with limited resources and no formal training, have proven that groundbreaking science isn't confined to laboratories or universities. Take the story of William Herschel, a musician turned astronomer who discovered Uranus in 1781. Herschel's homemade telescopes and tireless observations changed our understanding of the solar system. Similarly, Caroline Herschel, his sister, became the first woman to discover a comet and was later recognized for her meticulous cataloging of stars. Their work reminds us that scientific discovery thrives on dedication and ingenuity, not just institutional backing. Another notable example is Thomas Bopp, an amateur astronomer who co-discovered comet Hale-Bopp in 1995. While observing the night sky with friends, Bopp noticed a faint object that turned out to be one of the brightest comets of the 20th century. These stories highlight the vital role of amateur scientists in pushing the boundaries of what we know. Their discoveries often came from sheer love of the craft, spending countless nights under the stars, driven by a desire to understand the cosmos. In many ways, their work laid the groundwork for today's citizen science movement, where enthusiasts contribute to large-scale research projects. Platforms like Zooniverse and other online initiatives have made it possible for anyone with an internet connection to participate in scientific discovery, from identifying galaxies to tracking asteroids. This democratization of science ensures that the spirit of the amateur scientist lives on, proving that curiosity knows no boundaries. As we look to the future, it's clear that the contributions of self-taught researchers will continue to shape our exploration of the universe, reminding us that science is not just for the experts, it's for anyone willing to look up and wonder. Behind every great scientist is often a teacher who sparked their curiosity and nurtured their potential. These forgotten educators, though rarely celebrated, played a pivotal role in shaping the minds that would go on to explore the cosmos. Take the story of Margaret Geller, a renowned astrophysicist who credits her high school science teacher with inspiring her love for astronomy. He didn't just teach us about the stars, she once recalled. He made us feel like we could reach them. This kind of encouragement is what transforms a classroom into a launchpad for discovery. Another example is Annie Jumpcannon, a pioneering astronomer who not only made groundbreaking contributions to stellar classification, but also mentored countless young women in science. Her students often spoke of her patience and ability to make complex concepts accessible. One of them later wrote, "She didn't just teach us how to classify stars, she taught us how to see the universe with curiosity and wonder." Educators like these didn't just impart knowledge, they instilled a lifelong passion for learning. Their influence extended far beyond the classroom, shaping the trajectory of entire fields. In many cases, these teachers worked tirelessly, often with limited resources, to ensure their students had the tools and confidence to succeed. Their dedication reminds us that scientific progress isn't just about discoveries. It's about the people who inspire future generations to ask the questions that lead to those discoveries. As we reflect on the importance of education in advancing our understanding of the universe, it's clear that the impact of a great teacher can ripple across decades, even centuries. Their legacy lives on in every student who dares to look up at the stars and dream of exploring the unknown. Literature has always been a bridge between the complex world of science and the curious minds of the public. Long before the age of documentaries and podcasts, it was books and articles that brought the mysteries of the invisible universe to life for ordinary readers. Take the work of Camille Flammarion, a French astronomer and prolific writer whose books in the late 19th century captivated audiences with their poetic descriptions of the cosmos. His writing didn't just explain celestial mechanics, it painted a vivid picture of the heavens, inspiring readers to look up and imagine themselves as part of something vast and beautiful. One of his most famous lines captures this sentiment perfectly. "The universe is a grand spectacle, and we are the spectators." Similarly, John Michell, an 18th century clergyman and scientist, wrote about the concept of black holes decades before they were formally discovered. His writings, though overlooked for centuries, laid the groundwork for future discoveries and showed how storytelling could plant seeds of curiosity in the minds of readers. In the 20th century, writers like Fred Hoyle, who coined the term Big Bang, ironically, made astrophysics accessible through his novels and radio broadcasts. His ability to weave scientific concepts into engaging narratives brought the wonders of the universe into living rooms around the world. Another example is Cecilia Payne-Gaposchkin, whose groundbreaking work on the composition of stars was accompanied by her efforts to communicate these discoveries to a broader audience through her writing. Her clarity and passion made complex ideas feel within reach. These authors didn't just inform, they inspired. They reminded us that science isn't just about equations and data. It's about the stories we tell about the world and our place in it. By blending scientific rigor with the art of storytelling, they created works that continue to ignite curiosity and wonder, proving that the relationship between science and literature is as timeless as the stars themselves. The forgotten expeditions that mapped the invisible universe were journeys of both courage and ingenuity, yet their stories often remain untold. Take, for example, the Harvard College Observatory expeditions in the late 19th and early 20th centuries. Teams of researchers, including many women like Annie Jump Cannon and Henrietta Swan Leavitt, traveled to remote locations to observe the night skies. These expeditions faced immense challenges, from harsh weather conditions to the logistical difficulties of transporting delicate equipment. Despite these obstacles, they meticulously catalogued thousands of stars, laying the foundation for modern astrophysics. Another remarkable but overlooked mission was the Mount Wilson Observatory's solar expeditions in the 1920s. Researchers used innovative spectrographs to study the sun's atmosphere, revealing the presence of elements like helium decades before it was detected on Earth. These discoveries were groundbreaking, but they came at a cost. Researchers endured long hours, physical strain, and the isolation of remote observatories. Then there's the story of the Vela satellite missions in the 1960s and 70s. Originally designed to monitor nuclear tests, these satellites accidentally detected gamma-ray bursts, one of the most energetic phenomena in the universe. This serendipitous discovery revolutionized our understanding of cosmic explosions, yet the missions themselves are rarely celebrated. What makes these expeditions so remarkable isn't just the science they produced, but the human spirit behind them. These researchers ventured into the unknown, driven by curiosity and a desire to uncover the secrets of the cosmos. Their bravery reminds us that exploration, whether of distant stars or invisible forces, requires not just intellect but also resilience and determination. In the face of adversity, they persisted, leaving behind a legacy that continues to shape our understanding of the universe. The invisible universe has long been a canvas for both scientists and artists, who together have translated abstract concepts into tangible beauty. One of the most striking collaborations was between astrophysicist Jean-Pierre Luminet and artist Jean Mitchell Alamy. In the 1970s, Luminet mathematically modeled the appearance of a black hole, but it was Alamy who brought it to life through intricate drawings. These artworks not only captured the public's imagination, but also helped scientists visualize the warped space-time around these cosmic phenomena. Similarly, in the 1980s, artist Leah Halloran worked closely with astrophysicists to create paintings that depicted dark matter. Her work used swirling patterns and gradients of light to represent this elusive substance, making it accessible to those who might never grasp the complex equations behind it. Halloran once said, "Art allows us to see what we cannot otherwise perceive, to feel the magnitude of the universe in a single stroke of the brush." Another remarkable example is the work of digital artist Michael Benson, who transformed raw astronomical data into breathtaking images of nebulae and galaxies. His process involved meticulously layering data from telescopes like Hubble, blending science with artistry to reveal the hidden beauty of the cosmos. These collaborations remind us that art and science are not separate endeavors but two sides of the same coin. Both seek to explore the unknown, to make sense of the vast and often invisible forces that shape our universe. As physicist Brian Greene once observed, Science and art are both ways of asking the big questions, of reaching beyond what we know to discover what we do not. Through this fusion of creativity and discovery, artists and scientists have illuminated the invisible universe, bringing its wonders closer to us all. Behind every great discovery lies a story of support, often from individuals and institutions whose contributions go unnoticed. One such figure was James Lick, a wealthy 19th century businessman who dedicated much of his fortune to the construction of the Lick Observatory in California. His passion for astronomy stemmed from a desire to leave a lasting legacy, and his funding enabled scientists to explore the cosmos with unprecedented precision. Lick once wrote, "I would rather be remembered for the stars I helped reveal than the wealth I accumulated." Another pivotal figure was Andrew Carnegie, whose Carnegie Institution for Science funded early research into cosmic rays and the nature of the universe. His belief in the power of science to transform society drove him to support projects that others deemed too speculative or risky. In the 20th century, the Rockefeller Foundation played a crucial role in advancing astrophysics, providing grants for the development of radio telescopes. These instruments allowed scientists to peer into the invisible universe, uncovering phenomena like quasars and cosmic microwave background radiation. Astrophysicist Vera Rubin once said, "Without the generosity of these patrons, we might still be in the dark about the true nature of the cosmos." Institutions like NASA and the European Space Agency owe their success to the vision of policymakers and philanthropists who recognize the value of exploration. Their funding not only enabled technological advancements, but also inspired generations of scientists to push the boundaries of knowledge. Yet, the importance of funding in science remains a challenge, as many groundbreaking ideas still struggle to secure resources. As we reflect on the contributions of these forgotten patrons, it's clear that their investments were not just in science but in the future of humanity. Their legacy reminds us that the pursuit of knowledge is a collective endeavor, one that requires both visionary minds and generous hearts. Controversy has long been the spark that ignites scientific progress, especially in the study of the invisible universe. One of the most heated debates revolved around the nature of cosmic rays. In the early 20th century, physicist Robert Millikan argued they were high-energy photons, while Arthur Compton insisted they were charged particles. Their public clashes were intense, with Millikan famously declaring, "Nature does not indulge in such luxuries as cosmic rays of such energies." Yet, it was this very disagreement that drove further experiments, ultimately proving Compton correct and reshaping our understanding of cosmic particles. Another pivotal dispute centered on the existence of black holes. For decades, luminaries like Albert Einstein and Subrahmanyan Chandrasekhar disagreed on whether such objects could exist. Einstein dismissed them as mathematical curiosities, while Chandrasekhar's calculations showed they were a natural consequence of stellar collapse. Their intellectual tug-of-war forced the scientific community to confront the extremes of physics, paving the way for discoveries like the first black hole observations. Even the discovery of the cosmic microwave background radiation, the afterglow of the Big Bang, wasn't without contention. While Robert Dicke and his team were preparing to search for it, Arno Penzias and Robert Wilson stumbled upon it accidentally. The race to interpret their findings led to spirited discussions, with Dicke reportedly saying, "Well, boys, we've been scooped." Yet, it was this competitive tension that accelerated our understanding of the universe's origins. These clashes remind us that science thrives not in consensus but in the crucible of debate. As physicist Richard Feynman once said, "Science is the belief in the ignorance of experts." It's through questioning, challenging, and even disagreeing that we inch closer to the truth. The invisible universe, once a realm of speculation, has been mapped thanks to the passionate disputes that forced us to look deeper and think differently. The path to understanding the invisible universe is paved with forgotten experiments, whose brilliance often lies in their simplicity. Take, for instance, the work of Victor Hess, who in 1912 took to the skies in a hot air balloon to measure radiation levels at different altitudes. Despite the risks, his daring flights revealed that cosmic rays increased with height, proving they originated beyond Earth's atmosphere. This groundbreaking discovery, though rarely celebrated today, laid the foundation for modern particle physics. Another overlooked pioneer was Louis Leprince Ringt, who in the 1930s used cloud chambers to track cosmic particles. His meticulous observations captured the first photograph of a muon, a fundamental particle that continues to intrigue physicists. These experiments, conducted with rudimentary tools but boundless curiosity, opened windows into the subatomic world. Then there's Marietta Blau, whose work with photographic emulsions in the 1920s and 30s revealed the tracks of cosmic particles in stunning detail. Her method, though labor-intensive, provided some of the earliest glimpses into high-energy physics, yet her contributions were overshadowed by her male colleagues. Even the Millikan oil drop experiment, famous for measuring the charge of an electron, had an often forgotten counterpart, Harvey Fletcher's role in refining its precision. Together, these forgotten experiments and their creators remind us that science is a collaborative endeavor built on countless small steps. Their methods, though primitive by today's standards, were revolutionary in their time, proving that ingenuity often outweighs complexity. As experimental science evolved, these early efforts gave way to more sophisticated tools, but their legacy endures. They showed us that even the smallest observations could unlock the universe's greatest secrets, inspiring the next generation of explorers to keep pushing the boundaries of what we can see and what we can't. The study of the invisible universe has always required more than individual brilliance. It demands global collaboration. Scientists from across the world have pooled their expertise to tackle mysteries too vast for any one nation to solve alone. Take the discovery of the cosmic microwave background radiation, the faint echo of the Big Bang. This monumental breakthrough in 1965 was the result of teamwork between American physicists Arno Penzias and Robert Wilson, who built on earlier theoretical work by Soviet scientists Georgy Gamow and Ralph Alpher. Their combined efforts revealed the universe's infancy, forever changing our understanding of its origins. Another shining example is the International Cosmic Ray Observatory, a sprawling network of detectors spanning multiple continents. From the high-altitude observatories in Tibet to the vast array of detectors in Argentina, this collaboration has provided unparalleled insights into the high-energy particles raining down from space. But such partnerships are not without their challenges. Coordinating research across time zones, languages, and funding structures can be daunting. Cultural differences and political tensions have sometimes slowed progress, but the shared goal of discovery has always prevailed. As physicist Fabiola Gianotti once said, "Science knows no borders. It is a universal language that unites us in the quest for knowledge." This spirit of unity is perhaps best embodied by the Large Hadron Collider at CERN in Switzerland, where thousands of scientists from over 100 countries work together to probe the fundamental nature of reality. Their collective efforts led to the discovery of the Higgs boson in 2012, a triumph of international cooperation. These stories remind us that the universe's greatest secrets are too immense for any single mind or nation to unlock alone. By working together, scientists transcend boundaries, proving that the pursuit of knowledge is a shared endeavor that unites humanity. The history of science is filled with ideas that were once dismissed, only to be vindicated decades or even centuries later. Consider the case of Georges Lemaitre, a Belgian priest and physicist who proposed the idea of an expanding universe in the 1920s. At the time, many scientists, including Albert Einstein, were skeptical. Einstein famously called Lemaitre's theory the most beautiful and satisfactory explanation of creation to which I have ever listened, yet initially resisted its implications. It wasn't until Edwin Hubble's observations of distant galaxies provided concrete evidence that the scientific community fully embraced the concept, laying the groundwork for the Big Bang theory. Another remarkable example is the prediction of the Higgs boson, a particle theorized by Peter Higgs and others in the 1960s. For years, the Higgs mechanism was met with indifference or outright skepticism. Critics argued it was too speculative, and funding for experiments to test the idea was scarce. Yet Higgs and his colleagues persisted, confident in the elegance of their theory. Decades later, the Large Hadron Collider at CERN confirmed the existence of the Higgs boson, validating their work and earning Higgs the Nobel Prize in Physics in 2013. These stories remind us that scientific progress often requires patience and resilience. The scientists who proposed these groundbreaking ideas were not deterred by initial rejection or lack of support. They trusted their insights and continued to refine their theories, even when the odds seemed insurmountable. Their perseverance teaches us the value of open-mindedness in science, a willingness to consider unconventional ideas, and the humility to revise our understanding when the evidence demands it. As we explore the mysteries of the invisible universe, let us remember that today's dismissed theory might be tomorrow's cornerstone of knowledge. Public perception has always played a significant role in the progress of science, often shaping the trajectory of research in ways that go beyond the laboratory. Take the story of Vera Rubin, the astrophysicist whose work on galaxy rotation curves provided some of the first compelling evidence for dark matter. Despite her groundbreaking discoveries, the scientific community was slow to embrace the idea of an invisible substance making up most of the universe's mass. Public skepticism added another layer of challenge. Many people struggled to grasp the concept of something they couldn't see, leading to questions about the validity of her research. Media coverage at the time often sensationalized the idea of invisible matter, framing it as a mysterious or even fantastical notion rather than a serious scientific theory. Rubin herself once remarked, "It's hard to convince people of something they can't see, but that doesn't make it any less real." This disconnect between scientific discovery and public understanding highlights the delicate balance researchers must navigate. Media portrayals can either amplify curiosity or fuel misunderstanding. For instance, the discovery of cosmic microwave background radiation, which supports the Big Bang theory, was initially met with confusion. Headlines often reduce the complex science to simplistic or misleading soundbites, leaving the public with an incomplete picture. Scientists like Arno Penzias and Robert Wilson, who made the discovery, found themselves explaining their work not just to their peers but to a curious yet sometimes bewildered audience. The relationship between science and society is a two-way street. Public interest can drive funding and support for research, but it can also create pressure to deliver results in ways that are easily digestible. Astronomer Carl Sagan understood this dynamic well, often using his platform to bridge the gap between complex ideas and public understanding. He once said, "Somewhere, something incredible is waiting to be known," a reminder that scientific exploration thrives when society is engaged and informed. Reflecting on these stories, it's clear that the journey of discovery isn't just about uncovering truth. It's also about sharing them in a way that inspires curiosity rather than confusion. As we continue to explore the invisible universe, the dialogue between scientists and the public will remain as crucial as the science itself, shaping how we understand and embrace the mysteries that lie beyond our sight. Behind every scientific breakthrough lies not just the researchers in the lab, but the advocates who bring their work into the public eye. These champions of science often go unrecognized, yet their efforts are vital in turning abstract discoveries into shared knowledge. One such figure was Harlow Shapley, an astronomer who spent years promoting the importance of studying the cosmos. Shapley didn't just focus on his own research. He traveled across the country giving lectures, writing articles, and even appearing on radio programs to explain the wonders of the universe in terms everyone could understand. His passion was infectious, and his ability to connect with people helped spark a broader interest in astronomy. Another unsung hero was Margaret Burbidge, whose work in spectroscopy revealed the chemical composition of stars. Beyond her research, Burbidge was a fierce advocate for women in science, fighting for equal opportunities and challenging outdated stereotypes. She once said, "Science is not a male domain. It belongs to anyone with a curious mind." Her advocacy not only advanced her field, but also opened doors for future generations of scientists. Then there's George Ellery Hale, the driving force behind the construction of some of the world's largest telescopes. Hale understood that public support was essential for such ambitious projects. He wrote letters, gave speeches, and even persuaded wealthy donors to fund his vision, arguing that exploring the invisible universe was a pursuit worth investing in. These advocates shared a common goal: to make science accessible and exciting. They used storytelling, analogies, and real-world examples to demystify complex ideas. For instance, when explaining dark matter, they might compare it to the wind, something we can't see but can feel its effects. Their efforts went beyond education. They also shaped public policy. By highlighting the societal benefits of scientific research, they secured funding for projects that might otherwise have been deemed too abstract or impractical. Advocacy in science is about more than just spreading knowledge. It's about building bridges between researchers and the public. It's about showing people why the invisible universe matters, not just to scientists, but to everyone. As we continue to explore the mysteries of space, the role of these advocates reminds us that science thrives when it's a shared endeavor, one that inspires curiosity and wonder in us all. Failure is not the opposite of success, it's an essential part of the journey. In the study of the invisible universe, some of the most groundbreaking discoveries emerged from experiments that didn't go as planned. Take the case of Arno Penzias and Robert Wilson, who stumbled upon the cosmic microwave background radiation while trying to eliminate mysterious noise from their radio telescope. What they initially thought was a technical glitch turned out to be the faint echo of the Big Bang, forever changing our understanding of the universe's origins. This failed experiment earned them a Nobel Prize and opened a new chapter in cosmology. Similarly, Fritz Zwicky's proposal of dark matter was initially met with skepticism and dismissal. His ideas seemed too radical at the time, and many of his peers rejected his theories. Yet, decades later, his work laid the foundation for one of the most profound mysteries in modern astrophysics. These stories remind us that failure often leads to unexpected breakthroughs. As the physicist Richard Feynman once said, "The most important thing is not to stop questioning." Curiosity has its own reason for existing. Scientists like Vera Rubin, who faced countless obstacles in her career, exemplified this spirit. Her persistence in studying galaxy rotation curves, despite initial resistance from the scientific community, eventually provided some of the strongest evidence for dark matter. The process of science is inherently iterative, a cycle of hypothesis, experimentation, and refinement. Each failure is really a step closer to understanding. Edwin Hubble's early attempts to measure the distances to galaxies were fraught with errors, but his perseverance led to the realization that the universe is expanding, a discovery that reshaped our view of cosmology. What these stories teach us is that setbacks are not dead ends but detours on the path to discovery. They force scientists to rethink assumptions, refine methods, and explore new possibilities. As we continue to probe the invisible universe, we're reminded that every failure brings us closer to uncovering its secrets. Science, after all, is not about finding immediate answers. It's about asking better questions and embracing the unknown. Behind every great scientific discovery lies an institution that made it possible, yet many of these organizations remain unsung heroes in the history of cosmic exploration. Take the Mount Wilson Observatory, nestled in the hills above Pasadena. Founded in the early 1900s, it became a hub for revolutionary research thanks to its powerful telescopes. Here, Edwin Hubble first observed that galaxies were moving away from us, leading to the groundbreaking realization that the universe is expanding. The observatory's atmospheric conditions and cutting-edge equipment provided the ideal setting for Hubble and his contemporaries to peer into the depths of space, forever changing our understanding of cosmology. Another example is the Yerkes Observatory in Wisconsin, home to the largest refracting telescope ever built. Established in the late 1800s, Yerkes became a training ground for some of the most influential astronomers of the 20th century. Among them was Subrahmanyan Chandrasekhar, whose work on white dwarfs and black holes laid the groundwork for modern astrophysics. These institutions were more than just buildings. They were communities of curiosity where collaboration and innovation thrived. Then there's the Cavendish Laboratory in Cambridge, England, which played a pivotal role in the study of cosmic rays. Under the leadership of Ernest Rutherford, the lab became a center for experimental physics, attracting brilliant minds like James Chadwick and Patrick Blackett. Their work not only advanced our understanding of particle physics, but also paved the way for discoveries in cosmology. Across the Atlantic, the Palomar Observatory in California became a beacon of exploration in the mid-20th century. Its Hale telescope, one of the largest in the world at the time, allowed astronomers to capture detailed images of distant galaxies and nebulae. Scientists like Fritz Zwicky used these observations to propose the existence of dark matter, a concept that remains one of the biggest mysteries in science today. What these institutions share is a legacy of fostering discovery. They provided the tools, environment, and intellectual freedom for scientists to pursue bold ideas. Yet, their stories are often overshadowed by the individuals who worked within their walls. It's worth remembering that scientific progress is rarely the work of a single mind. It's a collective effort supported by institutions that cultivate curiosity and innovation. As we look back on these forgotten pillars of research, we're reminded of the role organizations play in shaping our understanding of the universe. They are the unseen catalysts, the silent partners in every great leap forward. While modern science has made incredible leaps in understanding the universe, it's important to recognize that the pursuit of knowledge about the cosmos is not a new endeavor. For centuries, indigenous cultures around the world have observed the stars, tracked celestial movements, and developed intricate systems of knowledge that reveal a deep connection to the invisible universe. These traditions, often passed down through generations, offer a unique perspective that complements and enriches modern scientific discoveries. One remarkable example comes from the Polynesian navigators, who traversed vast stretches of the Pacific Ocean using only the stars, ocean currents, and patterns of wildlife as their guide. Their ability to read the night sky with such precision was not just a practical skill, it was a profound understanding of the cosmos that shaped their world view. Similarly, the Maori people of New Zealand have long studied the Pleiades star cluster, known as Matariki, to mark the changing seasons and guide agricultural practices. Their knowledge of these celestial patterns was not merely observational but deeply integrated into their cultural and spiritual lives. In the Americas, the Maya civilization developed one of the most sophisticated calendars in history, based on precise astronomical observations. Their understanding of the cycles of the moon, sun, and planets allowed them to predict celestial events with astonishing accuracy. This system was not just a scientific achievement, but a reflection of their belief in the interconnectedness of all things. Modern researchers have begun to recognize the value of these indigenous knowledge systems. Dr. Dwayne Hamocker, an ethnographer who studies the intersection of indigenous astronomy and modern science, has noted, indigenous peoples have been observing and interpreting the night sky for tens of thousands of years. Their knowledge is not only scientifically accurate but also deeply meaningful, offering insights that can enhance our understanding of the universe. This recognition is leading to collaborations that bridge the gap between traditional wisdom and contemporary research. For instance, astronomers working with Aboriginal Australians have used their elders' knowledge of the stars to identify celestial phenomena that were previously overlooked. These partnerships highlight the importance of diversity in scientific thought, showing that the universe reveals itself in different ways to those who approach it with curiosity and respect. By acknowledging the contributions of indigenous knowledge, we not only honor these traditions but also expand our collective understanding of the cosmos. It's a reminder that science is not a single path but a mosaic of perspectives, each offering a piece of the puzzle. As we continue to explore the invisible universe, let us remember that the stars have been speaking to humanity for millennia, through the eyes of scientists, navigators, farmers, and storytellers alike. Their voices, though often unheard, are an integral part of our cosmic journey. The future of mapping the invisible universe is brimming with possibilities, driven by groundbreaking technologies and the relentless curiosity of scientists. Advances in radio telescopes, gravitational wave detectors, and space-based observatories are pushing the boundaries of what we can observe. For example, the Square Kilometre Array, set to be the world's largest radio telescope, promises to reveal hidden galaxies and uncover the mysteries of dark matter and dark energy. Similarly, the James Webb Space Telescope, with its unprecedented sensitivity to infrared light, is already transforming our understanding of the early universe and the formation of stars and planets. These tools are not just instruments, they are gateways to realms of knowledge that were once beyond our reach. Leading these efforts are visionary researchers like Dr. Priyamvada Natarajan, an astrophysicist whose work on dark matter mapping has reshaped our understanding of cosmic structure. She has said, "Every time we build a new tool, we're not just answering questions, we're discovering new ones, and that's the beauty of science." Another trailblazer is Dr. Jocelyn Bell Burnell, whose discovery of pulsars opened a new window into the universe. Reflecting on the future, she notes, "The next generation of astronomers will have tools we can't even imagine today, and they'll uncover wonders we've yet to dream of." As we look ahead, the potential for collaboration between disciplines is immense. Artificial intelligence, for instance, is revolutionizing data analysis, enabling scientists to sift through vast amounts of information to find patterns and anomalies that would otherwise go unnoticed. Projects like the Event Horizon Telescope, which famously captured the first image of a black hole, are just the beginning. Future initiatives aim to create even sharper images and explore phenomena like wormholes and quantum fluctuations. The quest to map the invisible universe is not just about technology, it's about humanity's enduring desire to understand our place in the cosmos. As Dr. Neil deGrasse Tyson has said, the universe is under no obligation to make sense to us, but that doesn't stop us from trying. This journey is far from over. With every discovery, we're reminded of how much we've yet to learn. And that's what makes the pursuit of knowledge so exhilarating. Whether it's peering into the heart of a black hole or deciphering the whispers of gravitational waves, the future holds endless opportunities to explore the invisible universe and uncover its secrets. And as we move forward, we're not just observers, we're participants in a story that began billions of years ago and continues to unfold with every new discovery. The importance of remembering these scientists lies not just in recognizing their achievements, but in understanding how their work shaped the very foundations of modern science. Their discoveries, often made against tremendous odds and with limited resources, laid the groundwork for the tools and theories we rely on today. Take Cecilia Payne-Gaposchkin, for instance, whose groundbreaking research revealed that stars are primarily composed of hydrogen and helium. At the time, her findings challenged established beliefs, but today they are fundamental to our understanding of stellar evolution. By honoring her and others like her, we acknowledge the courage it takes to challenge the status quo and push the boundaries of knowledge. Historians often emphasize that these scientists were visionaries who saw possibilities where others saw limits. Dr. David Kaiser, a science historian, notes, "Their work reminds us that scientific progress is often driven by individuals who dare to think differently, even when their ideas are initially dismissed." This legacy of innovation and perseverance continues to inspire researchers today. Contemporary scientists like Dr. Andrea Ghez, who was awarded the Nobel Prize for her work on the supermassive black hole at the center of our galaxy, frequently cite these early pioneers as sources of inspiration. Ghez has said, "Their curiosity and determination remind us that the universe is full of surprises, waiting for those bold enough to seek them out." Beyond inspiration, their contributions have practical relevance. The techniques and technologies developed by these forgotten scientists are still in use today, from radio astronomy to gravitational wave detection. Their work has also paved the way for interdisciplinary research, showing how collaboration across fields can lead to groundbreaking discoveries. As we reflect on their legacy, it's clear that their impact extends far beyond their own time. They've not only expanded our understanding of the cosmos, but also demonstrated the power of human ingenuity and resilience. In a world where scientific progress is often taken for granted, their stories serve as a reminder of the dedication and creativity required to unlock the secrets of the universe. By remembering these scientists, we honor not just their achievements, but their spirit of exploration, a spirit that continues to drive us forward as we seek to map the invisible and uncover the unknown. As we wrap up this journey into the stories of these remarkable yet often overlooked scientists, it's worth pausing to reflect on the profound impact they've had on our understanding of the universe. From the meticulous mapping of the cosmos by individuals like Henrietta Swan Leavitt to the groundbreaking theories of pioneers such as Subrahmanyan Chandrasekhar, their contributions have reshaped our view of the stars and beyond. These scientists didn't just observe the universe, they interpreted its language, unlocking secrets that had been hidden for millennia. Their work reminds us that progress often comes from those who dare to question the unknown, even when the world around them is slow to recognize their genius. The significance of their discoveries extends far beyond their lifetimes, influencing modern technologies like satellite navigation, space exploration, and even our understanding of climate change. Their legacy is a testament to the power of curiosity and perseverance, qualities that continue to drive scientific inquiry today. As Carl Sagan once said, "Somewhere, something incredible is waiting to be known." These words capture the essence of what these scientists embodied, an unyielding belief that the universe holds endless mysteries, and that with dedication and imagination, we can uncover them. Their stories inspire us to keep exploring, to keep asking questions, and to never stop seeking answers. If you've enjoyed learning about these forgotten figures, consider diving deeper into their lives and discoveries. Share your thoughts in the comments below. What scientist story resonated with you the most? And if you're eager to uncover more space mysteries, don't forget to subscribe and join us on this journey of discovery. Together, let's continue to celebrate the unsung heroes of science and honor their contributions to our understanding of the cosmos.